and let's get started. And thanks everyone for being here. This is so awesome. My name is Ray. I'm a developer advocate for the Google Cloud Platform. What that means is that I like to bring some of the latest, greatest technology that Google has to offer to developers all over the world. But there's another side of my job, which is to try to make our products better. And I have been in the industry for 15 years now, mostly as a Java developer. And I love to make things easier for Java developer to use. And that's why I started and worked with the engineering team on this project called Spring Cloud GCP. So if you ever use Spring Boot, anyone here use Spring Boot? Yeah, just about everybody. Yeah, exactly. If you want to try something with Google Cloud, check this out. And the best way to contact me is on Twitter @Satanism. And today we also have a special guest.
All right. Hello, everyone. Thank you for being here. Today you get like 2 for 1, basically. I'm also a cloud developer advocate on the GCP platform. And I'm like looking mostly after our storage and data products, so Cloud Spanner, Cloud SQL. Also very interested in distributed system. I'm not a Java champion, but I have a lot of fun with Java. So I'm really glad that Ray invited me to join his talk today.
And thanks for being here. And just so you know, we did not coordinate on the T-shirts. It just, no, seriously, like I had no idea.
This is just really good unspoken communication.
Yeah. So hopefully, everything works in this session as well. So we do have a combined experience of about like 30 years, right?
Roughly 30 years. So for me, it's like 10, 15 years ish.
Yeah. And like we developed this demo just for you all.
Right, it's super beautiful, right? Like that's what you can do with 30 years of experience, right?
That's because we're not front-end developers.
Yeah,
we're
keep it simplistic,
back-end,
right? Keep it simplistic. We have two of the major colors. Well, a little bit of shade of gray there.
Yeah.
A little bit unalignment. So our CSS skills are definitely not up to par to the Java skills that we might have.
And this is just bootstrapped, something we can create very quickly. However, it does demonstrate some really, really powerful points about microservices. So for example, it does do very interesting things, extremely, extremely interesting and popular thing. If you say hello to it, it's going to say hello back to you. We're also going to store this in a database. So Robert, I think you did the backend for this, right?
Right. So the most important part is to keep your data, right? Keep it consistent and keep it persistent. So
And I did the hello world service, so I said hello back. That's to the extent of my
and you put this line there.
I put that line there. The one in the middle. Yeah, exactly. So however, it is a microservices architecture. It's multi-tier. We do have the front end. We have the 2 services, and one of the services talks to MySQL, and we have session application with a session store with Redis, and all of these are deployed into the Kubernetes cluster. So we can actually go ahead and take a quick look. So this is a little visualization tool that I use for demonstrating what's running the cluster. So here we can see very clearly we have 1, 2, 3, 4, 5. So in my cluster, I got 5 nodes. I created them in Google Cloud, and it's just a matter of point and click. We say I need 5 nodes, and we got 5. We also deployed the entire stack into this production environment by using the Kubernetes YAML files, the descriptors. So for example, for the UI, I can go in here and take a look at the UI deployment. Yeah, and we can document everything, all the declared states that we want Kubernetes to deploy. Here specifically, we say we have 2 instances, and if I scroll down a little bit, I can see that I'm running the container image. And similarly, every box here that corresponds to these 2 things, right? And then correspondingly, we have these load balancers that we can create directly in Kubernetes. And these are known as services. And I also created the service. For example, here we have the UI service. What this will do is to listen on port 80 and forward it to port 80 and so on and so forth. However, we do want this application to be usable for everybody. And so we created an external load balancer. And what that's going to do is to create an external IP address on Google Cloud Platform. Yeah.
Right. So really, like bottom line here, TLDR about Kubernetes. You basically describe your state, and Kubernetes takes care of like deploying that state to the resources that are available to the cluster.
Yeah. And it's all abstracted away. It doesn't matter which environment you're running on. Now, why don't we go take a look at it very quickly? So with this external IP, I can click into it. Now, notice how the other ones don't have external IP, right? The other ones only have internal IP. So we can see very clearly on the top, like we got a Spring Boot icon here. So that's really nice. It's a Spring Boot application after all. And let's go take a look. Wait a sec.
Can you do hard refresh?
What's that? Hard refresh? Yeah. Well, how do you do that?
Shift R.
Shift R. No? Well.
All right.
Let me close the browser. Hold on a sec. not
Maybe
good.
like 6 minutes in.
5, well, not even 6 minutes in.
Yeah.
Yeah.
I mean, like there's a lunch break afterwards, right?
There's a lunch break, right? Do they have beer? Is that?
Anybody hungry?
Yeah. Well, thanks for coming. I think.
Really sorry, like there's the whole talk, right?
Yeah. Yeah. Well, so actually, I don't know. Like, you probably go to a lot of these conferences, watch all of the talks, and you see live demos, and sometimes you just wish that the demo just fails, and you just want to see how that looks like. You're getting that today, unfortunately. I guess we can debug it in 5 minutes, right? We can fix everything in 5.
Like another 5 and another 5 and another 5.
Yeah, exactly.
But let's look at this. Like,
okay.
Amazing error page, right? White label error page.
Yeah, white label error. So I didn't spend a lot of time to, I didn't expect any errors, to be honest.
Right, and we don't have a backup, right?
Backup?
Video? Something?
Weren't you supposed to make a video?
Me? I thought, like, our unspoken communication.
Well, that worked for the T-shirt, but I thought you were supposed to. So we have no video with no backup.
Right. Let's analyze this.
Let's take a look. So this error message, doesn't really look nice. I mean, this is probably one of the worst error messages ever, because you get to see that this is internal server error with 500. So we know what that means.
Yeah, 404.
And we got a 404, which I don't know why. Look here, a null pointer. So there's only one thing that we're sure. It is a Java application. Like, that's the only thing that we know.
Definitely.
Right. But we don't know why any of these other two things are there.
Right. And we didn't expect any errors, so we didn't do any nice error pages, right?
Yeah, no. But, wait a second. We have, like, this is a production environment, right?
Right. So we should have something like a staging environment and QA environment and stuff like that, right? So let's have a look. In Kubernetes, we actually have a way to separate different stacks, basically, or landscapes from each other, which we, like, with namespaces. So what you can actually do is, like, you saw the YAML configuration files that Ray showed earlier, and you can just take them one-to-one and deploy your entire stack to a new namespace. And so basically your application works in that new namespace. They share the resources that you have available in your Kubernetes like cluster, but everything else is basically isolated.
So for example, here we have the production namespace, which is default. And then we can see the same application deployed with the same configuration in the staging namespace. Oh, thank goodness, I do have a backup here. Right. So that is good.
So let's look like there. We should have another external IP for our service, right?
Yeah. So let's take a look at that. Yeah. So here's the service. Only for staging, you can see the IP address is different. So let's go take a look. So this is production. It's obviously not working, unfortunately, but we do have a backup here with staging. Oh,
yeah, it works.
Well, of course it works.
Cool.
Let me say hello, and it only works if the data is stored. Oh, okay, it does work. So of course it works. It is staging.
Right.
Why would you ever go to production without having it work on staging, right? Like, of course this works. I'm kind of expecting it to work, but it doesn't work in production.
Yeah. So we need to find out what's different here, right?
Okay. So I think that when I deploy staging, I use exactly the same configuration. So I'm pretty sure it's not a configuration issue.
Yeah.
Maybe are we sure? Are you sure? Like it's actually running exactly the same image?
Let's check. So we can actually check what we have deployed. So in our deployment file, in our deployment YAML, we actually define like the image.
Yeah, there we go.
We define a version, right?
Yeah. So here we have the registry for the Docker container, and here's the name of the image. It's Hello World UI, and I'm using the latest tag to run the latest version of the app.
Latest? Are you serious?
Yeah, it's a CI/CD, right? We always run the latest and continuously deliver to the production environment. No. No? Wait.
All right. So Ray, what happens if you, for instance, you build the code on your machine, you push to the container registry, and I haven't pulled it down for a week.
Well, that's your fault.
What is my latest pointing to? What is your latest pointing to?
So your latest is whatever you put down a week earlier.
Right. So
why didn't you put down the latest one? That's my question. So first thing here is obviously, like, this is not a great thing that I have done, is it?
No.
Right. We should always, like, tag it properly with the right versions, so you always know which version of the application you're running, and you should never overwrite the tag that you already produced, because otherwise we could be running two different things. So since I did deploy the same thing across two namespaces, what that means is maybe the staging environment latest is the different one from the production one.
Correct. So let's find out. So what we can do in Kubernetes, we can actually use the describe command and find what's actually running. So let's look in our production one first. What's running there?
Okay. So let me just So production one. So I can describe. Okay.
Right? We see like the environment variables that are set. We see some like mounts that we have, the ports that are mapped, and we also see the image ID that got deployed there. Right? So we have the beautiful 1, 2, 3 many characters char checksum. So to compare them, let's do something here. Ray, you're going to remember the first 4.
Okay.
I'm going to remember the last 4, and everybody else remembers everything in between, okay?
Yeah.
You got this? You got this?
Pick a character that you're going to remember, but don't remember which digit they're on, basically. No, I was kidding, yeah. So the SHA ID uniquely identifies this particular image, right? So if the SHA ID matches up, we're pretty sure they're running the same code, right?
Yeah, for now.
So you got this? 0, 3, 4, 5, you got this, right?
All right, yeah.
Ends with a B, yeah, just so you know. All right, so now we can go into the namespace for staging, of course, and we can find a pod there that's running also. And then we can also do this describe a pod. Oh, sorry, describe the pod. Describe, if I can type, there we go. And then the name of the instance. And then we can clearly see, even in staging, they are using the same configuration. And if I scroll up a little bit, 0, 3, 4, yeah, that's what I got.
624B, everybody checks out?
Yeah, it's exactly the same image, yeah.
Human checksum?
Yeah, there you go. Somebody checked that one, right? Anyways, so we know it is exactly the same image. I'm pretty sure they are, because I also, it's
all right, so we know what that the images are the same, but what actually went into these images? Can we find out what went into the image? We want to know like what was built into the images. Yeah,
so typically what you want is that you want to associate metadata to any artifact that you build. So if you're building a Java artifact, you will associate the git commit plugin so you know exactly which branch, which revision this came from. Similarly, when you build a container, you also want to somehow associate metadata about where the things came from. And in different registry systems, there are different ways of doing it. We happen to have this in Artifactory right now. So I can probably go to the Artifactory site here, which I do have my container hosted. And one of the really neat thing that you can do is to actually do a search so that we can know exactly which build this application came from, because we do have the metadata. So we can go to search, and where is that checksum? Let me see here. The checksum is that one. So we can do a search. Again, you can do this in a different registry as well, but you can find the checksum, and we will tell you all the matching tags.
So version 50. So we could have used the version tag there.
Yeah, we should have used version 50 here, right? Even if you have CI/CD, you should always update the tag to the latest tag that you know is actually being built. And so we can actually go in here, so we can see a little bit about the metadata associated with this container image. For example, we can see the name, blah, 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 deployed by Mark. You're not Mark.
You're not Mark either.
That's none of us, is it?
That's a mystery. All right.
Yeah, but at least we know somebody deployed it, so that's okay. But it's all recorded here.
We blame it on Mark.
Yeah, exactly. Mark is not here, so that's fine. And then we can go into the build. We can see how exactly this is built. For example, again, if you have the right metadata, you should always be able to go back to the revision. So in this particular container, we can see that this came from a few artifacts here. Guestbook example snapshot.
So version 001-snapshot.
Yeah, snapshot. Yeah.
Really, you keep making the same mistakes.
Yeah, the latest one, right?
Oh no, this time it was Mark, right?
Yeah, we got like 4. Yeah, exactly. But you get the gist, right? You want to know what's inside of a container, and if you need to ever troubleshoot something, those metadata is going to be very, very important. But at this moment, I think we're pretty good in terms of we know what we deployed. We know that it works in staging. We know that in production, we deploy exactly the same thing that's been certified, in this case by Mark, and we know that this should work. So I don't know, what's next?
All right, so we need to get more insights, right? We need to get a step down further. So let's look into the logs.
The logs, yeah. So typically, this was not useful at all, right? So how do you usually get the logs in a non-Kubernetes system?
Right, so some of you might remember going back in the days, you had to, if you had an application running on multiple systems, you had to SSH in, you had to unpack some log files, pull them down, put them in some kind of format where you could search it and correlate things, and it probably takes a while, right? Yeah. So with Kubernetes, you actually have the possibility to stream the logs directly to your command line interface. So you can use kubectl logs-f and then the pod.
Yeah. Now, hold on a second. You did say that back in the days. Now, how many people are still doing that today? SSH into the machines. Yeah, there you go. Yeah, I expect a lot of people still do that, today. So
apologies.
Yeah. So we can actually stream the log. Now, Robert, we do have 2 instances running here. even in the VM world, if you have 2 VMs, what are the odds for you to find this error message in one of these instances?
Well, my rough guess would be a 50-50 chance.
Yeah, okay, 1 in 2, that's pretty good. But in a microservices deployment, right, we may not only always have 2 instances, right? Sometimes we have, like, say, 10 instances, or maybe you have auto-scaling. Maybe you have 100 instances, you just don't know. What happened here? Huh?
Scaled.
Oh, yeah, it did scale, yeah. So let me see here. So I thought I saw an error message for a second. Now we have 10 instances running. Now, Robert, what are the chances now for you to find this particular error message in one of these 10 instances?
Well, you make it really complicated. I would say it's still 50-50.
What?
Oh, it's like either you find it or you don't.
I guess the outcome is one or the other, right? I never understood the math problems. I'm not very good with math, so
Me neither.
I'll trust you on that one, right? So let's see how lucky we are. So I'm gonna do a little trick here. I'm gonna find the one that's been running for a while. I'm going to just go ahead and stream the log so you can see what that feels like. And we're pretty lucky today. We should go buy some lottery. So we do find this arrow, and we can see this arrow. But it's not guaranteed that if I come back to this page, I go to this particular instance to see the arrow.
Right. So, and then, like, if you don't find it there, you have to, like, go to all the 10 others or 9 others to find it, right?
Right.
So we need some way to actually aggregate or, like, all of them into one. So there are some tools out there that help you with that. So Kubetail, for instance, or Stern allows you to get all the logs from your deployment. So we use here the Hello World UI deployment. And all the parts that are reporting to that deployment, basically, we get all the logs color-coded in our command line interface, which is great, but you can imagine what if you have a production environment? How would that look like?
Well, it will be like Matrix, right? You'll see these letters falling down the screen, and there's no way for you to respond to it, right? It's really colorful. That's really
right.
nice.
And then you have maybe 10,000 lines of buffer, so the error is going to go pretty
exactly.
quickly, right?
Yeah.
So,
look at that. Yeah. So there's no way for me to kind of extract any information from here. Now, typically, what you want in a Kubernetes installation is you want to have a centralized logger so that we can pull all the logs together and store them in a centralized location. In the open source world, you have something called like the Elk stack. You have Elasticsearch, Logstash, Kibana, so you can automatically aggregate all the logs together. We are running on Google Cloud, so what that means is we, by default, will install the centralized logger called Stackdriver logging. So regardless of where you run it, it doesn't matter. Just make sure you have a centralized logger.
Right, and really important here is to always log out to standard error and standard out, so that the agents can pick that up and then aggregate it into a centralized logger.
That is a very, very good point, because if you wrote to the file system, you will have other issues. Yeah.
Right, so let's have a look into our centralized logging. So we're going to go to logs, and then we have all the services basically that we have available in the Google Cloud platform, and we have the GKE container there. We have our cluster, demo 2. Then we have our namespaces. Our production runs in the default namespace, so let's go in there. Then you can drill down and filter on the deployment or like on the container name. And then you have some other drill downs that we're not going to use right now. And then let's search for exception.
Yeah. Oh, yeah. So there's a lot of things so we can find exceptions. And there we are. We do have a few exceptions, and
right.
We do see the full stack trace now, which is kind of nice. So we can kind of say that, oh, this is HTTP client error, something happening in between the communications maybe. But this is a very, very good start.
Right, and we have our 4.4 and our null pointer exception there, so we're getting closer.
Yeah, we're getting like 1/3 of the way there, right? However, as I had done production like support in the past in a hospitality company, they do have like 10 machines. I remember having to download all these logs and do all the analysis. But one of the things that was really important for me at 2 a.m. in the morning is to kind of get more information. Like, is this issue only happening on one machine, or is it on all of the machines? Because if it's happening on just all of the machines, that means I'm not going to go back to sleep tonight. I have a major, major outage.
Right, and if you have it on one machine, you just kill the machine, right?
You just kill the process and you restart it, just like what everybody else does with the JVM.
Right. Who has done like used the cron job, for instance, to restart the JVM because it runs out of memory and after 3 days?
Do that every week. Yeah. There's always some people do it. Now, just so you know, we do have cron jobs within Kubernetes as well. You can kill a pod whenever you want. But don't do it that way. Yeah, you don't. No. You use it as a chaos monkey, but not just because the application does not work. Now, that being said, we do want to extract more data from here. Now, typically, what you would do is do a lot of pearls and grapes and all that. but with the right tooling, like this one, for example, we can send it to a different sinks. So for example, if you want to extract real-time or near real-time data from your logs, you can send it to a messaging system like Cloud Pub Sub. But my favorite is actually using BigQuery because internally at Google we have something called Dremel, which allows us to query logs at massive scales, or we can query anything at massive scales, really, with SQL statement. So I actually have BigQuery export already configured, so we can actually go and try to figure out what is wrong with this application, maybe from more data from the logs. Okay?
Cool. So like now we can actually undust our SQL skills here, right?
Yeah. I mean, who still writes SQL? Not me. Well, I haven't done that for a while, but I do have one pre-created. So I'm not going to write one right now, but I do have one pre-created. So this is the SQL statement that we can use to like query the logs.
Right, so let's have a look here. So what we're going to do is we filter on the exception in the text payload. We're going to look for the container name hello world. We look for the resource type container. We look in the table, so we create tables per day for your log. So we look into the table which is for today, and then we aggregate by the name and the occurrences. So we see how many exceptions are happening per container that's running right now.
Yeah, and this is all happening with structured data without any indexes. So it doesn't matter how big the data size is, right? We can query the logs in this way, which is really nice for us to get more information from the data, right? That's a very important attribute here. Now we can clearly see one of the instances actually is having more issue than the other. What do? We can go ahead and find that instance, and we can restart it. Maybe. No, don't do that.
Yeah, no, not a good thing. Like if we restart it, we basically lose all the evidence. Yes, we have the logs in our centralized logging, but there might be some other issues with this container, which is still with this container. So if you actually delete it, it gets stopped and all the evidence is gone with it. So what we actually want to do is we want to isolate it. We want to take it out of the live traffic. And we want to basically investigate that container, like what is wrong with it. Right. So what we can actually do with Kubernetes is we have labels that we use to route traffic. So we have our deployment where we attach the labels to our pods, right? And they can be arbitrary, so you can define them yourself. It doesn't matter. It doesn't there's no you just need the key and value basically, right? And then we have our service, which is looking after certain labels and then routes traffic to these labels. So we have here our app hello world and the serving true.
Yeah. So this label is again arbitrary, and I chose the serving label here. And on the other side, on the service side, right, we have the selector. So this is how we select within Kubernetes on which of the backends to route to. And with the serving label, I can really just take this particular container out of service if I want to. So just to show you what that looks like, if I do a get pods with -L serving, so we can actually see the different labels associated with each of the pod. Like we got 10 container here, 10 pods here that all has serving equals to true, and one of them, in theory, is causing me a lot of trouble. So rather than killing it and restarting it, I want to investigate a little bit more. So what I can do is to do a label override. Okay, so here I can do kubectl label, and I can specify the name of this pod, and I can override the label, and I can set the serving label to false. And what that's going to do is that now the load balancer will no longer route traffic to it, and then we have effectively isolated this particular instance from serving any traffic for now.
But if somebody counts very quickly, you see that we have now 11 of these pods. So what's actually happened is because we took that out of the load balancer, but also out of the deployment that is taking care of that pod, the deployments are like, oh, now I have only 9 pods serving traffic, but I need 10. So Kubernetes started a new pod to have, again, 10 pods serving the traffic. So now we have 11, and you see here one, which is very young.
Yeah, and now since the traffic is isolated from this particular instance, which is really, really cool, and now we can do all the things that we would otherwise want to do to an instance like a local application, for example. So for example, I can SSH, or this is what we call exec. We can get into the shell of this particular container, and then we can do all the default troubleshooting that we would do. So for example, maybe we can find the PID for the Java process, and we can do a kill 3. I think that's how you get a thread dump. and sometimes maybe you want to attach, JStat or something else, so you can understand what is happening to this particular process. So you can do all of that here. You can also find other files, whatever, if you have actually written some metrics here. But now we can also say attach a real debugger, or sometimes you want to just
sometimes you just want to check out like how this pod is serving traffic. So what we actually can do is we can do a port forwarding onto our local machine, which is really powerful. All the wiring, all the network wiring is taken care of for you by just executing one command. So we have the port forward command here. We use the pod, and then what you cannot see unfortunately here is you use the local port, which we will use 8081, and then the remote port, which is basically the pod serving the traffic on. So we're going to do 8081 to 8080 remotely, and then we're going to go to this application, localhost.
And this is done through a secure tunnel as well. So now if I go to 8081, again, it will route traffic to that specific instance within the Kubernetes cluster, and it actually works.
Nice. So it's not a problem that is specific to the pod. Right?
So if I go to production, no, definitely not specific to the pod. Like anybody can probably go here right now and, but I definitely have issues, right?
All right, good. So the problem is somewhere else, right? So we need to get more insights in like what is actually happening.
Right.
So we could potentially now put the pod back because we know that it's not specific to this pod. So why don't you do that? Like, let's put that pod back.
Yeah. So to put the pod back, you just have to set the serving back to true. However, remember, Kubernetes, I said I can only have 10 instances running. If you put this back into serving mode, then you have 11 instances running, and Kubernetes will ultimately still have to remove one of the instances from the pool of 11. Now, there's some heuristic behind it, so it's not guaranteed that this particular instance will still be serving application again. So you can put it back, or you can just simply just take it out. You can delete it and pretend like you never needed it in the first place, right? So there are many different ways to do it, but I can put it back to serving, right? And just pretend that we troubleshoot it, it's not working.
Right. So you saw in the beginning we have a really, really complex and difficult microservice architecture, right? So you have like a service A calling B, calling C, calling D, and that can go all the way down. So we need to find out like what is actually happening, what is actually happening in real life. We want to get some more insights. So Ray, you had this beautiful graphic, which I assume you didn't build because it's kind of beautiful.
Wow. Actually, you're absolutely right. The creator of one of the creators of Kubernetes, Brendan Burns, actually wrote this initial version.
Right. So, but what we see here is, if you remember how that looked like in the beginning, we only had 2 pods showing there, and now we actually show 10 pods. Yeah. So this seems to be kind of real life. So, Ray, are these lines that show like where the traffic is going? Is that also real?
Yeah. I mean, so you can clearly see in this graph that I got these lines, that's drawn from one pod, one container to another. So we know for a fact that Hello World service is talking to the guestbook service. However, this is not a visual diagram. This is not a visual, just so you know. Like, this is so live. But you got me, except for the connections here. Why? Because these lines are actually drawn only because I told it to draw it. And the way I've done it is by using my YAML file. In here, in the annotations, I specifically said that this application is talking to these services, right? So anybody could have added anything here that may not actually be true.
Right. So how many of you have debugged the problem based on documentation till somebody tapped you on the shoulder and said, like, what are you actually looking at? This is not how it works today.
Right. Yeah.
Right. So usually, like the time that you write documentation, it's already out of date. Developers are prone to really bad at keeping documentation up to date. So since this is kind of a documentation, we don't really know if this traffic is actually happening. So we need some more observability in our application, what is really, really happening. So we have actually something there deployed in our Kubernetes cluster, which inspects the network traffic, which is vscope. So Ray is going to do a port forwarding into this container which is running this in our cluster, and we see there that we have some traffic going on.
Yeah.
Right.
So this is a weave scope that can be deployed in pretty much any Kubernetes cluster, and we can go in there and see the traffic. This is network traffic coming from Hello World UI that's talking to Redis, right? Hello World UI talking to Zipkin and a few other things. But we can clearly see there's no connection to guestbook service for that matter, right? But maybe there is, and maybe that will go through. But it's a pretty good indication of, are your services connected? Are they physically talking to each other via the network?
Right. So we see the bits flowing here.
Yeah.
But that not necessarily helps us. Right, so we need more insights into what is actually happening. So like our microservices on a higher level, we want to actually have like request level insights, right? And that is like, so what we want to have is we actually want to know like when a request comes in, how much time does it spend in the respective microservices? Like what are the latencies there? What are like the return codes that we get? Like where is actually the error happening? So we need like distributed tracing here, things like Zipkin, Spring Boot Sleuth, or open sensors, right?
Yeah, and the way that all of these distributed tracing work is by having a unique trace ID that's being generated on the first request, and then you're responsible for propagating it downstream for every of the subsequent requests. And so in the end, your logs can be correlated to a single trace, and also all of the subsequent requests can be correlated to the same trace. And then additional things will help you to build a beautiful tree of exactly what happened in your service across multiple microservices. Now, you can use Zipkin, you can use Jaeger to do the visualization. We also have a little proxy that you can run so that you can actually see some of these data directly in the console as well. But it doesn't matter where you see it. Just make sure you have some similar tooling that allows you to get observability into your application. So we can come here and we can see some traces, in this case in Google Cloud. So we can see a lot of traces here.
Yeah, so let's filter down. We knew that there was like a 500 somewhere happening, right? So we can actually, this looks like a successful one.
Yeah, that's a successful one. So I can see a successful request goes through every messages here, and we are able to load everything. What was the error? What was the status code again?
Like 500-ish.
Oh, it's 500-ish, yeah. So we never know which one. So I'm going to do 5XX. That means 500-ish. And here I can see the trace that's associated with the 500 error. Oh, there we go. Yeah. So in this view, I can see that very clearly. My application made a call to this other service, so my application returned 500, and my service here took 5 milliseconds to execute. And it is a Spring application, and somewhere along the way, oh, there we go. That's where the 404 came from. So we know very clearly now the 404 is caused by this particular service, right? So that's pretty good. We're getting somewhere.
Yeah, we're getting closer. We're getting closer. But we still don't know, like, why is this 404 thrown there, right?
Yeah.
So we want to get more insights in this. Like, we want to dig even deeper. Like, what would we do here in this situation in a normal like application that is running, right? So, who has debugged the system out in print lines? Really? Really? Everybody else is lying.
Well, haven't you done it, Robert?
I have done this plenty.
Plenty of times, okay.
Yeah, I'm guilty. But so basically what you would do is, right, you need to know, like, what is the code that is running right now in your production environment. Pull this down from Git or your favorite version control system. Do, like, some, like, print line debugging or some kind of, like, getting in more insights in what is happening, like something that is more written to your log files. And then, so basically creating a hotfix and then deploying this hotfix back into your production system. So who is deploying within 20 minutes into a production system?
Anyone here that can
Anyone?
debug?
Oh,
yeah, that's pretty good. Yeah,
pretty good.
That's
all right.
impressive.
Your turnaround time is pretty good. Yeah. Who, like an hour?
Everybody else.
All right. Who, multiple days? Multiple days?
Well,
right.
In an emergency situation, you kind of need to like do it faster, right? Yeah.
Right. Yeah. You wanna do something faster, right? You want to get insights more quickly, and you can't afford like the round trip times of like deploying the hotfix, understandings like, okay, we still don't have enough information. We need to add more log output, and so on and so on.
Yeah. Yeah. If you discover that you need more log output, then you have to go back and do everything over again. Now, Robert, I think you told me you have a strategy on how to add log messages, right?
Right. So I'm usually doing the binary search.
What does that mean?
Well, I'm adding a log line at the beginning of the function, which says like I'm here, and then that is step 1, and then I'm adding something at the end of the function and say like this was successful. Step 2.
I swear I've done a lot of that as well. But going through that binary search, even though you're doing a binary search, you still have to redeploy, right? We can do better. So there are some debugging agents, for example, on Google Cloud, that allows you to add log messages directly to your running production application without changing your code. And that is something that can be very, very helpful in this situation. So for example, my application actually has been configured to use this special agent here, right? So I'm going to remove a few things here. Basically, what this does, remember I said, always have the metadata associated with your code and your container. In this case, we do have the Git metadata produced by the Git commit plugin. And in this particular console, it can actually read the metadata, check out the right code, check out the right revision of the code, represent it here for you. And we can actually add log messages directly into production environment like this. So you did say you do a lot of system prenines.
Yeah.
So we can do the binary search here if we want to. We can say click here. And what do you usually do? Like number one?
Yeah, let's do one. I'm here.
I'm here. OK, let's do that. Yeah, very good. So now we have this log message propagated to all of the running instances. And you did say you do one at the end.
Yeah.
Right? Like
2 success.
Yeah, success. Yeah, there you go. Success. Right? And obviously, we probably don't get here, so we can add something in between. So maybe somewhere along this statement, right? So I'm going to say the name is...
Maybe we can put a variable in there. Yeah, maybe.
There we go.
Yeah.
Name is name. So I want to see what the name is actually is, right? And we can infer these variables directly from the scope of this particular log line. Now, of course, you don't believe me unless if I show you that's actually there, right?
Right, let's check it.
So I'm going to go back to my application here. I'm going to do a quick refresh. And just like that, magic. The log is there. I'm not even going to show you. Just kidding, no. Of course, you have to see it to believe it. So remember all the tooling that we talk about? We can use Stern, we can use kubetail, we can find the pod. We can also use centralized logger. We can go ahead and find this particular log message. And let's just do some troubleshooting here to find it. So all I want to do is to see the log coming from hello or UI.
Right, and let's search for our one I'm here.
Oh, so here's the exception, right? Yeah. And if I scroll up a little bit, that's the exception. And if I scroll up, oh, look at that. So there's the log point of I'm here. And the name is empty.
All right.
You didn't put a name in there.
Ray, you didn't put a name in there. This smells like user error.
That is definitely a user error.
Right.
So we're not going to fix it, right?
Right, yeah.
No. So it is actually my error. I guess I did not put the name in. So that gets us somewhere, right? Because sometimes it's really, really difficult to reproduce the issue that's happening in production. You don't know what the users have done. You just don't know because you never tested that case in staging. Because that's just the difficult thing. But troubleshooting line by line, we can do what Robert's favorite way is, right? So we can actually go back here and say, number 1A, like I'm here now, right? We can do this for every single line of code if we want to.
Right. But this is not the real way, right? When I asked how many did system out debugging, there were only a few hands. So what is the rest doing? Is the rest doing attaching a debugger? Who is attaching a debugger for debugging?
Into production?
Into production?
Yes.
Really?
Hands? Do I see hands? No?
Really?
Yeah. Well, I think that was a really good way, right? Because somebody comes to the site, it will be like, oh, there's no response, and you get a page and say, there's no response from the site, and you get code, right? Robert, what happened?
And then we step through it, and everything works. Yeah, everything works.
Yeah, that sounds like a really good way to have job security, right? They never figure out why the site stopped until they call you, right? Yeah. But that's the reason why you don't attach the production debugger, because we're going to stop the world, and nobody's going to be happy.
Right, but wouldn't it be cool if you actually could kind of attach a debugger to your production environment and see actually what the values are of your variables and what's actually happening?
Yeah, and that's exactly what this thing can do also. So in addition to being able to add new log messages, we had a theory here. So the theory here is that the empty name is causing the URL to be generated in my client side so that it is calling something that returns 404. So I can here go into my client here, right? I have a log message here. But what I can do also is to take a snapshot. Now, when you are taking a snapshot, it's really that. It's taking a snapshot in moment in time, and it does not stop the world. So what I can do is potentially, let me show you this. I'm going to come back here, and I'm going to do this side by side so you can see the magic here. So if I do a refresh, it's going to trigger that line of code, and then we're going to take a snapshot, and you saw that right there. Was it too fast? I think I missed it. Yeah, right there. Right? And here we can see all the variable in scope. And the theory here is that we generated the endpoint that is actually without the name. If we go in here, we can actually investigate and look into the Java objects. And we can clearly see here the endpoint is in fact what we see in distributed tracing. If we really want to test it, we can go back and do the curl command, and we will actually see that this is actually a 404. And not only that, we also get to see all of these other code stack along the way.
Right. And so some might ask now, isn't that expensive? But it's actually not that expensive. It's basically we are really taking a snapshot during your production traffic. We are doing this inside of Google with pretty much all of our applications, and it takes like a single-digit, very low single-digit hit on in terms of like utilization for your applications. Now, that is pretty amazing. Can I do this within IDE as well?
You actually can. So if you use like something like IntelliJ, you can install the Google Cloud, the plugin. And from there, you can open up the source code, and then you can also attach the debugger directly from your local environment, so you don't have to upload the code to anywhere else. And then you can, from IntelliJ, you can actually add this capability as well, which is super nice and easy to use. I don't think I have the right application running here, do I? Oh, maybe I do. Maybe I do. So here, if I go and load the project, this very large and complicated application. There we go. Yeah, there we go. And I think that somewhere along the way here, we can add a configuration here that has a Stackdriver debug, right? So from here, you can add a debugger. You can select the project. Now, one of the most frequently asked questions is, well, does it actually work? Does it have to work in Google Cloud? And actually, no. You can actually run your application anywhere else, and you can use the same debugger through the console that we provide, right? So, sometimes it's really nice to have the right logging, the right ways to debug things, with a lot of data. But at the end of the day, you still need some additional information, right?
Right.
Yeah.
And there's actually some other cool things that we have under the Stackdriver umbrella. So you, for instance, can also get alerted for like new errors that are happening, right? So you have this error thing there.
Yeah. So like the question here is like, if you have a centralized logger where you have all the error messages, don't you wish you have more value out of that? Right, so I know a lot of centralized loggers, they probably do something intelligent with like machine learning to help you identify issues, right? That's all the benefits of helping you to identify issue. But how many people here actually wake up, Friday morning at 8 o'clock and say, I wonder what new exceptions I have today? Anyone? Yeah, there's one person really? That's before the coffee or after the coffee, right? So, right, wouldn't it be nice if the tool actually tells you that? So these are the things that you kind of get from some of these tools in centralized logging, where, for example, here, because we have all the error messages, we actually get to see all of these logs, and then we can extract the errors, and we can go in there, and you can actually see the frequency of these errors, and so on and so forth. Now, the beauty of it here is, sometimes you see, like, I think that's a cross-site XSS scripting error, right? So somebody's trying to hack our site, and that generates exception. These are really important to kind of pick up before they actually hacked it. Or the other thing is maybe you see a growth of errors, and then that's ultimately going to lead into a production outage. You want to get notified for that pretty much automatically.
Right, and a really strong feature that you have here is actually in the top. You can actually acknowledge these errors, and very important, mute it.
Mute it? Why would you ever do that? Yeah, I mean, if you don't want to see this error ever again, you can mute it, of course. And similarly, with some of these tooling, like with trace, if you have the trace data centralized stored, and then you can analyze it. So whether using Zipkin or Jaeger, or in our case, Stackdriver Trace, one of the things is that you should be able to get that data around, and you want to understand the performance characteristic of your application. So you can actually build a latency distribution graph, so you understand the 99% percentile of the latency, and so on and so forth.
Right, and you see if you have any like performance regressions from version to version, so you can make assessments of that. You can basically roll back based on these things, and you can investigate even further what's going on there.
Yeah. Yeah, so you can actually build reports from some of these tooling, which is going to be really, really powerful, and we'll notify you as well. All right. So let's go back and do a quick recap of all the things that we kind of talk about. So I'm going to skip over all these slides because we've done everything with our demo. So I'm happy that the application didn't work. And then let's go do a very quick recap of a few things. Right.
So first of all, logging, really important. Log as much as possible and use a centralized logging, right? Like, so log to standard out and standard error, which can be picked up by an agent that is running in your infrastructure, and then streamed into a centralized logging sync.
Yeah, and also being able to extract information and metrics from it. That's going to be very important. And of course, in a microservices architecture, it's a complicated soup of connections, and you do want to have some kind of observability into what's happening behind the scenes. And for that, I would say, definitely start with distributed tracing. You don't need to trace every single request, but at least have some facility to do that. Because I know a lot of people go into microservices without this particular feature or like overarching solution. And when something do go bad, you would have absolutely no idea exactly what's causing it. And this is going to be really, really useful.
Right, and with the new debugging features that we have with Stackdriver debugging, you can actually live debug your production environment. So you can actually put debug statements into your code and see like what's happening there. So add like log lines basically, and then you can also get snapshots of your production traffic to have a little bit more comprehensive view on like what's happening in your application.
And if you want to attach a real debugger that stops the world, just remember to isolate the instance so that it's not causing a production issue anymore. And one of the most important lessons here for me, Robert, is don't deploy with latest. Is that right?
Or build something with snapshot.
Yeah, or build something with snapshot. Always version it. Always have some metadata associated with your artifact so that you can go back and have a traceability on the artifact side, not just on the request side. Okay? And so remember, we do have a lot of tooling for it, like centralized logging, trace, debugger, and monitoring, and so on and so forth. Okay?
All right. And if you want to find some more information around this particular talk or other talks by the famous Ray, you can go to xanonism.me/talk. You find a list of talks from Ray. And we also have a comprehensive documentation under cloud.google.com/Stackdriver for all the Stackdriver portfolio that you have there, monitoring, log, debugging, and so on.
And and all the source and all the demos, everything I deployed, you can reproduce everything and play with this as well. So with that all said, thank you so much for being here. I really appreciate it.
Thank you very much.
Yeah, thank you.